This is section 2.2, and in this video we're going to be adding and subtracting rational numbers. Just to kind of give you a little bit of warning, so to speak, I need you to be able to recall all the basic rules when adding and subtracting fractions and decimals, and all the rules when adding and subtracting integers. All of these things are going to be combined together today. So here's the truth. If you don't know how to add and subtract fractions and decimals by this point in time, you need to come talk to me as you're going through this section, because you need to be able to know how to add and subtract basic fractions. On top of that, you need to know how to add and subtract integers, because those rules with working with negative and positive numbers are coming back as well. So if you're struggling with any of this, you need to come talk to me. Do not just sit there. All right, now, so let's look at this very first problem. We have negative 4/5 plus 3/20. Now, we should know automatically, based upon fractions, that we cannot add this like it is, and here's the reason why. This denominator and this denominator are not the same. And since they're not the same, we cannot add them. And so what we have to do is find what's called the LCD, the least common denominator. The least common denominator for both 5 and 20 happens to be 20. Okay, so I'm going to write that down. So what I want is to change this fraction to an equivalent fraction where the decimal is 20. And this fraction we can basically keep the same. And we know that this is a negative. So I have to ask myself, 5 times what number gives me 20? Well, it happens to be 4. So that means I can take that 4 and multiply that 4, and I get 16. If I have totally lost you just now, you have to come find me, all right? Otherwise, we're going to keep moving, because I'm having to assume that you know what the LCD is, all right? Now that we have negative 16 over 20 plus 3 over 20, we can treat this like a normal fraction. We know our denominator is going to stay the same, so I'm going to write that down. And this time, my negative is going to come up here. So this is going to be, negative 16 plus 3. All right? Hey, since my denominator doesn't change, the only thing is our numerators. We have negative 16 plus 3. Well, that follows our integer rules. We know what to do here. So negative 16 plus 3 gives us negative 13. And the denominator never changed. So our final answer is negative 13 over 20. Now, this next one's a little bit tougher. I have negative 8 plus a negative 6/7. All right, so this one, in all truth and honesty, I already know the answer from an easier way of doing it, but to avoid confusing you, I'm going to show you a same method that will work every time when you're adding and subtracting fractions. And the best way for you to do things is to take fractions and put them in improper form. All right, so if you know what that is, it's basically just rewriting it. So let's kind of go through this, and I'm going to have to do this on another piece of paper. Okay, so we have 2, and I have negative 8 plus a negative 6/7. So the first thing I notice is that this is an integer, all right? And my job is to make this into a fraction. Well, the easiest way to take an integer and change it into a fraction is by simply rewriting it as 8 over 1, all right? This right here is the same thing, because negative 8 divided by 1 is negative 8. So plus negative 6/7. Now, since I've got this written as an improper fraction, I can continue to do so. And what I want to do is make my least common denominator. Well, the easiest least common denominator that I can use is actually the number 7. So I'm going to put this as 7 plus a negative 6/7. And I've got to figure out what this number is. So what did I multiply that 1 by to get 7? Well, I multiplied it by 7. So 8 times 7 will give me 56. So now I have negative 56 over 7 plus negative 6 over 7. All right? So now what I've done is I have the same denominator. So now I can just use my denominator at the bottom. And I'm going to say negative 56 plus negative 6. And when I do, I can follow my rules using integers. Negative 56 plus negative 6 will give me negative 62 divided by 7. All right, so here's the thing. It's a fraction. I'm done-ish, but not completely. It says in the simplest form. This is not in simplest form yet. We might be able to do a little bit more with it, so we're going to do a double check. So what we're going to do is actually divide now, because this is what it's saying, negative 62 divided by 7. So I'm going to kind of rewrite that up here. Negative 62 divided by 7. Okay? And since I know that these two are different signs, I know my answer is going to be negative. So I know that automatically. So 7 can go into 62 how many times? It can go into it 8 times. All right? Oops, let me move that 8 over a little bit. It can go in there 8 times because I know that 7 times 8 is 56. All right? And then when I subtract 62 minus 56, I'm going to get 6, a remainder of 6. Well, here's the thing. This should be something that's reviewed. Since I know that my remainder is 6, I can just simply say that it's 6 as my numerator and that 7 is my denominator. So my answer is 8, negative 8, and 6/7. Now, you're probably thinking, well, Mr. Lewis, why couldn't I just have put them together in the first place? Because look, negative 8, negative 6/7, they're both negatives. They're both being added together. It makes negative 8 and 6/7. And you're exactly right if you thought that. However, sometimes, especially like when we get to 3, it doesn't work as easy. This is not as nice. So that's one reason why I'm talking about switching things over to an improper fraction and coming up with the least common denominator and then solving it out that way. All right? It really helps us when we get to problems like number 3. So speaking of 3, let's write that one down. Let me do this to the side here. I have 3. I have 1 2/15 plus a negative 3 1/2. All right? So my job is to add these numbers. So let's go ahead, and since I'm working with fractions, let's change them into improper fractions. And if you don't know how to do that, I'm not going to review it in this video because you should know it by now. But if you don't, you need to find me. So let's work with this one. I'm going to take the denominator 15 and multiply it by 1. Okay? And I get 15. And then I'm going to add it to the numerator to get 17 over 15. All right, so I have rewrote this as an improper fraction, 17 over 15. Now I'm going to do the same thing here. In this case, we know that it's going to stay a negative, so it's going to be plus a negative. And 2 times 3 is not 2 times negative 3. We're not doing that because this is just talking about the number. We're not worried about the negative because we've already written it down. So 2 times 3 gives me 6, plus that 1 gives me negative 7/2. All right, now that I know what my 2 improper fractions are, I can find my least common denominator. Well, take a moment, see if you can figure it out. My least common denominator in this case is going to be 30. All right, knowing that, I can find out what my numerators are. 15 times what number gave me 30? Well, in this case is 2. So 15 times 2 is 30. Therefore, 17 times 2 is 34. All right. Now, my next job is to find the numerator for my next piece. And I did 15 times 2 to get 30. So I need to do 15 times 7. So 15 times 7, and I can do it on the side just so I can do it. 15 times 7 is 35, carry the 3, That's going to be 105. All right. Now, I have a common denominator, so I'm going to write that down. And it's 34 plus a negative 105. Well, according to our rules and everything, we can solve for 34 plus negative 105. We can kind of do this. I'm going to do 105 minus 34 because this is my largest absolute value. I'm going to subtract and I get 71. But because the 105 had the largest absolute value, it's going to be negative 71 over 30. All right. So I've got an improper fraction, but let's go ahead and try to change this to a mixed number. So let's rewrite this. 30 will be divided into negative 71. Can 30 go into 71? Yes, it can. It can go in there 2 times. All right. So I'm going to take that to see 60. That's going to leave me an 11. And 30 cannot go into 11, so I'm just going to leave that as a fraction. So 11 divided by 30. So is this a positive number or a negative number? Well, recall that I have 2 different signs. So my answer is negative 2 and 11/30. Going back to this answer, we have negative 2 and 11/30. All right. Let's be honest. I'm going to be honest with you. This is not easy to do by hand. But if you can remember these steps about the positives and negative integers, and you can remember some of your fractions, it can be done. Once you get your calculator, though, it's going to be a whole lot easier. But for now, you're not going to have your calculator. All right, so why don't you try 4, 5, and 6 on your own? What you should have got was negative 7/12, then negative 2 and 1/10, and then 10 and 7/12. Now let's try 7, 8, and 9. So I'll do 7 with you. And this one's a whole lot easier. When you're working with decimals, it is easier, okay? So we have the number 0.46, and we are going to be adding 0.642, and that is a negative number. All right, so here's my problem. So since I am adding an opposite and a negative, we're going to have something here, okay? So we need to ask ourselves which one of these two has the largest absolute value. Well, in this case, it's going to be here. So my largest absolute value is going to be 0.642. My smallest absolute value is going to be 0.46. And now I just simply subtract. All right, now don't forget, since this has 2 decimal places, I need to put a 0 in the place of there for a placeholder. 2 minus 0 is 2. 4 minus 6 doesn't happen, so we have to borrow from the other side. So 14 minus 6 gives me 8. 5 minus 4 gives me 1. And so I get 0.182. However, don't forget, what was the sign of the largest absolute value? In this case, it was negative. So my answer is going to be negative 0.182. And as you can see, that is a whole lot easier to work with than fractions. Okay? So why don't you try 8 and 9 on your own? Don't forget to follow the correct rules. For 8 and 9, you should have got negative 5.57 and 0.91. All right. Again, you know the drill. You need me, come find me. All right, so number 10. Tubs of ice cream are delivered to a store at a temperature 36.7 degrees Fahrenheit. The ice cream is stored in a negative 40-degree freezer. When a tub is brought out of the freezer, the temperature is negative 22.2 degrees Fahrenheit. Write the difference between the temperatures of the ice cream after the ice cream is in the freezer and before it is in the freezer. All right, so there's a lot of information here, but look at what the question is asking. It says, what is the difference between the temperatures after the ice cream and before the ice cream. So you see this number right here, the -40, that's just talking about the freezer. We only care about the temperature of the ice cream. When we look at that question, it's saying write the difference between, it's asking for the 22.2 degrees and the 36.7 degrees because these are the temperatures of our ice cream. This is just the temperature of the freezer. It has nothing to do with the ice cream. And now it's asking us to find the difference between these two numbers. So there's one of two possible answers, one to two possible ways. I can either say 36.7 minus 22.2, or I could say 22.2 minus 36.7. So take a moment, pause the video, and figure out which one of these expressions is correct, because only one of them is correct. So let's look at this sentence before I give you the answer. It says, write the difference between the temperatures of the ice cream after the ice cream is in the freezer and before it's in the freezer. So it says that the first thing we're looking at is after, the after temperature. Well, the after temperature was 22.2. And then we're going to compare it to the before temperature, was the 36.7, according to this very last sentence. So the correct expression that we need is this one. Okay? And this would be incorrect because this one is the before and this is the after. It's wanting this way. Now that we can just simply subtract, I will give you it too. It's going to be -14.5 degrees Fahrenheit. So the temperature dropped by -14.5 degrees. All right, so 11 is going to be your challenge problem for this video. And as always, you know what to do. Come find me if you need me, and I'll see you in the next video. Bye-bye.